Network protocols can be defined at any layer in the OSI model. So we can have a protocol defined as an application layer protocol, as a presentation or session layer protocol, even though in practice we don't use those. We can have a transport layer protocol, a network layer protocol, a data link layer protocol, or a physical layer protocol. And a network protocol is simply a set of rules that define how a message will be structured for transmission. This set of rules is important because the receiver is going to apply the set of rules in reverse to decode the message from a bit stream transported over the physical layer. Historically, protocols have always been used in communication, especially electronic communication. In Morse code, in the days of the telegraph, stop was used at the end of sentences to indicate that a sentence had reached a period. In radio voice procedure, which is still used in some radio communications, certain keywords are used to indicate controls in the transmission. So for example, radio voice procedure might involve one station sending some kind of message, and at the end of that message saying over, meaning that that station is waiting for the station with which it was communicating to respond. And that other station may send a message and say over again and go back and forth until finally we reach the end of communication and one of the stations says out. So protocols have been a major component of communication systems. It's just with digital communication systems like we have today with networking systems, we're encoding and decoding these messages using computers, and computers are much faster and can understand things typically more quickly than humans can, and therefore our control sequences are different. They could be binary sequences, they could be text sequences, but they are encoded digitally and processed automatically. The problem that the protocol solves, however, is still that we need some way of determining where a message starts and where a message ends. And we might also need ways of determining what order a message is coming in and coming up with a way of getting a message from one end to the other reliably. We'll talk more about that in future videos. So any network protocol that we design connects one layer on one device to the same layer on another device. So each layer of the OSI model adds some control information to the message. It adds some features that we can use for our communication. Ultimately, the physical layer is what connects the two devices together, and the physical layer carries a stream of bits containing the message that's been encoded in all of the protocols defined by the layers above it. Now, as I mentioned before, a protocol connects a layer on two different devices. So if I have an application layer protocol or a layer 7 protocol, I'm connecting the application layer on one device to the application layer of another device. Of course, in order to do that, I have to descend through the different layers on the first device and ascend up the layers on the other device. I can have protocols at any of the 7 layers. The layer 1 protocol would define the electrical communication or radio communication or optical communication patterns and techniques that would be used for physically getting bits from one place to another. Above that, however, all my protocol implementations tend to be in software. In practice, we typically do not use layers 5 and 6 or the session and presentation layers. So here's an example of a real network protocol stack. At the application layer, we can use an application layer protocol such as HTTP. Again, we skip the presentation and session layers and go straight to the transport layer where we might use TCP, or the Transmission Control Protocol. Below that, we might use the Internet Protocol, or IP. And we might have our IP network running on top of Ethernet, which has an Ethernet data link layer, and we might be using 1000 base T or gigabit Ethernet copper connections as our physical layer. When we send a message from one machine to another, that message has to traverse the network stack or the protocol stack on both devices. Each network device has an implementation of each network protocol that it can recognize at each layer. So if we support 3 or 4 different network layer protocols, for example, each device in our network is going to have implementations for each of those possible protocols. The messages that we're trying to send from one place to another are wrapped in and then extracted from these protocols. So if I send a message, that message is going to be sent at the application layer, and the application layer is going to do whatever it's going to do, and it's going to wrap that message into some transport protocol structures. The transport protocol structures are going to get packed into network protocol datagrams. The network protocol datagrams are going to be packed into data link protocol frames, and the data link protocol frames are going to be converted into a bit stream sent over some kind of physical medium, and the result is going to be a stream of bits on that physical medium. At the receiving end, that stream of bits comes into the physical layer of the receiver and gets broken up into data link protocol frames. The network protocol datagrams are then extracted from those data link protocol frames, and the transport protocol structures are then in turn extracted from the network protocol datagrams. Finally, the original message can be reconstructed by the application layer from the transport protocol structures. So what we end up with is an end-to-end communication system that looks a bit like this. The message goes to the application layer of the transmitting system. We skip over the presentation and session layers because we don't use them in practice, and we go to the transport layer, the network layer, the data link layer. The message finally goes out on the physical layer, and at the other end is extracted from the physical layer to get data link frames. Those frames are then the information from those frames is then extracted to get network layer datagrams, and then the transport layer structures are extracted from those. Finally, the application layer can extract the message, and we get the message from point A to point B.